This week we will try to learn a little bit more about the use of classes and some of the contexts we can actually apply them in. So, what are we going to look at this year? We're going to use especially at the use of const in function parameters, especially when passing arguments by reference, which is quite common with classes. Passing objects to functions in general, so an instantiation of a class, returning objects from functions, overloading operators, and the concept of a friend of a class, which I particularly find quite useful. So, let's start with a refresher and introduction. And what I'm really going to do is I'm going to build up a piece of code. So, let me start it up slowly to illustrate a few of the ideas we've already seen, at the same time adding to our understanding, I hope. So we've got a class we're going to define which will have contain vectors of length 3, so they call the class vector 3, and it will contain some private and public data as usual. So let's fill in the private data first. So there's 3 variables in there, x, y, and z, which are all initialized to 0. And then we need to add some public functions in there. So we first add a constructor. We add a default constructor, which is just vector 3 equals default. A parameterized constructor, which takes some doubles and produces a function argument, and a destructor, which as usual up to now will only print out when it's called. We need some more to that. For example, access functions, so typically setters and getters, which in this case are called set x, y, and z, and get x, y, and z, which are kind of blindingly obvious functions. And then finally, we have to define functions to print out what a vector is. So we call that function show, which prints x, y, and z on output in a nice format. And a nice other function you might do is function that adds a scalar to all the arguments, so increases both x as well as y as well as z by the argument. Okay, that looks quite beautiful, but let's talk a little bit about that. Clearly you would like to apply it, so you add a main function to it, which now sets up a vector a, which then would be all set to 0, a vector b, which just enters 1, 2, and 3, and a vector c, which is minus b, so it has minus 1, minus 2, and minus 3 in there. I can print out those functions. I can add the scalar s to one of those objects and show it again, and at the end I can return 0, so the output would clearly not be surprising. 0, 0, 0, 1, 2, 3, minus 1, minus 2, 3, and minus a half, 1, a half, and then since I've got 3 vectors in this function a, b, and c, we shouldn't be surprised that our destructor gets called 3 times. So that all makes total sense. Let's see what we can do next. There are some elements that we could do better. The first idea is to think about const. We first introduced the const modifier when defining constant data type, like for example const double m sun in kilogram is that number typed on the screen over there. But a const modifier is actually very, very handy in function parameters lists. So, for example, if I pass something by reference, it's very useful because void myMember function const reference my object. If I don't say const, in principle, I could change my object inside a function. This way I can still pass by reference, but I can also can't change it. The second example is applicable to member functions of a class. So now the const is not inside the function, but outside the function. And what it really does, even though double is not a constant, the function is constant, which denotes immutability, which really means that member data are not modified. So use a const function wherever appropriate. It gives even more data protection and avoids stupid mistakes. So that naturally brings us to the idea of passing an object to a function. We already saw it over there. If I, for example, would define a dot product function, which would take 2 arguments, both of types vector 3, let me call them v1 and v2, and they're both constant functions, obviously, and I could define a function, a double function like that, which would do double result v1.getX times v2.getX and add everything together and then return the result. Notice the factor of 3 objects are passed in exactly the way as a double or an integer would be. They're also passed by reference. The more complex an object is, the usually more efficient it is to pass it by reference. And we have used the public access functions, the getters in this case, of v1 and v2 to get their components. Well, we'll see that that's not the most elegant, most efficient way of doing things. But if you do that, you can add the following lines to the code. So you can calculate the dot product and output the dot product. That's no problem at all. It does the job, but the function is now not part of the vector3 class. And realize that the dot product is really a function that is inherent to the vector3 class. So you hardly need classes for the way you've done it over here. And it lacks the idea of object-oriented programming, where both functions and data are part of an object. So it would make much more sense to encapsulate this function and make it part of the class. So let's see how we can do that. If inside the class we define a function which only takes a single vector as an argument, same structure, it's also a function that doesn't change any of the internal data of the class, and what it then does, it multiplies x times v of x, y times v of y, z times v of z, and that clearly is rather different because it's only one argument needed, because if I let that function act on an object, one of the objects is already there, it's only the second object I need to pass it. So it's easy to see by an example. If I could replace that previous statement by double dp is b dot product c, so the x, y and z data over here comes from b, and v actually gets substituted with c. So b is the object calling the function and c is the argument of the function. Okay, very good. In principle, a vector3 class is a valid return type. What I'm doing over here is one that adds two vectors together. I could add a member function, create a member function to add two vectors together, which would read vector3 plus constant vector3 and v, constant again, and I declare a temporary function. I set temp to these values and then I return temp. That's perfectly fine. We can then add the following lines in the main program. You call this function as such. A new vector d is initialized as b plus c essentially, and then I can output that and show that. Okay, perfectly fine. Again, b is the calling object and c is the argument of the function. Rather than modify the data of b, we've declared a new vector inside the function and it sets its component using the access functions. Note we have used the default constructor of vector3 from within one of its own member functions, which is perfectly legal. Alternatively, I could of course also use the parameterized constructor and written all of that in one line, which is probably the slightly more elegant and more efficient way of doing it. So that makes a lot of sense. There's also the idea, but plus is actually an operator, and we might actually want to define the symbol plus rather than the word plus. And this is a useful technique you can apply in C++. Not all object-oriented programming languages allow it, and the main reason is that essentially if you allow overloading, the meaning of the new operator doesn't have to be linked to the meaning of the operator in another context. But this idea is particularly useful when our objects are mathematical constructs, vectors, complex numbers, where the plus or minus or times has a well-defined meaning. An example, we can overload the function of the plus operator to use our vector3 class. So inside the class I could define a function vector3, and now it's rather than the function plus, I write operator plus, which is very much like a function. It takes a constant vector3 reference argument and it's a constant function as well, and the rest of the structure is the same. So this is actually a way to define an operator. So an operator is a function, effectively. I could, for example, call it in the following silly way, vector3 eb dot operator plus c, e dot show. So this replaced the plus we had before by operator plus, and you would be right, it's perfectly correct C++. It would work and produce the same result as the plus function. But instead, how about we write vector3 e b plus c without the operator? That would be much nicer. This gives the same result. And effectively what we've done, we've overloaded the addition plus operator to include an action on vectors. We can also overload the plus operator with other arguments. For example, you could define a scalar addition, which we had before, vector3 operator plus. Now the argument is different, so overloading the function is fine because the compiler can check which function we're using, and it adds the same scalar to every single argument of the function and returns the result. And that makes it really nice to make a very much more clever statement. You can actually overload most operators. The most commonly one used are plus, minus, times, divided by, plus equals, so that's the increment operator, sometimes plus plus, square brackets, etc., etc. But I would argue that we have to be careful to use a sensible meaning for these operators. Their meaning must be linked to the meaning in other contexts. If it's totally different, it gets unbelievably confusing, and then we hit the objections why, for example, a language like Java does not allow me to overload operators. It's open to abuse. Overloading using a member function always requires an object to be on the left of a vector, an operator. What happens then if you want to left add a scalar, right? We had e plus 1.5, but now if we want to write 1.5 plus e. You cannot use a member function of the object e as it appears on the right hand of the expression. Right? It goes there, not there. There's a way around that. I can overload a non-member function instead. I can define an operator plus, which returns a vector 3, has two arguments, a scalar and a vector, and I then can just do exactly what I did before. This is relevant whenever the class of an object on the left, in this case the built-in double, cannot be modified, and clearly you have no access to what a double is, so there's no way to add an additional function to that member class. There's another closely linked idea, which is the idea of friend functions, friend objects. Another controversial one. I like it, but some coding styles think this is bad, okay, essentially, so it's not universally approved. The previous non-member functions requires the use of the access functions, the public functions of the class, to get the vector coordinates, because I don't have direct access to the private data members. No way at all to make the function a member function. Problem with that is that the function is separate from the class, and one of the main features of object-oriented programming is encapsulation, including all data and functions acting on that data in one class, and clearly this is not it. So what do we do about it? Well, we can make a non-member function a friend of a class, which is a halfway house. Functions that are friends are ordinary functions, but can access member data of friendly objects in a parameter list instead. So how does it work? For our left addition function, we can put the following line inside the class. Friend, vector3 operator plus, double scalar, const vector and v. So it's the same statement, the only thing we added is friend. It's a top declaration. So the function itself is not declared, it's a pre-declaration of the function. It says the function is a friend function. The class private access permission is granted for member data of the object parameter. So our function could now look like vector3 operator plus, double scalar, const vector and v, vector3 and the same conventions as before, return temp, etc. Since the function is now a friend of vector3, we can directly access the private data belonging to the object v. The procedure is similar to putting our member functions outside the class. Always include the declaration inside the class. Good practice to group both types of functions together. I find it quite useful, much easier to understand what all the options are. So, let's summarize. We have discussed the following ideas: the use of const in function parameters, passing objects to functions, returning objects from functions, overloading operators, and friends of classes. There's a really nice demonstration code on the course website called aclassfinal.cpp, and I really would recommend you look at that.